So we're now going to move on to our next presenter. Jerry McLaughlin is the CEO of Life Biosciences. For my longevity journey started by going to Life Biosciences website to understand a little bit more about what these guys were up to, and fascinating work going on there. A lot of transition, of course, within the organization as well. So Jerry, are you with us today? I can't see you on the screen yet, but I'm sure you're here.
I am here.
Oh, great.
I should be on the screen.
Yeah, gotcha. Good to see you. So,
okay, great to see you.
You've got a lot of work going on with the work that you're doing, Jerry. We did an interview with Joan a little while ago, just to understand a little more about what was going on in her world. So, are you ready to present? And we'll catch up at the end.
That's great. That sounds good. Thanks very much, Phil. And I really appreciate the invite. It's a pleasure to speak at the Metabesity conference and share a bit about Life Biosciences. And me being relatively new to the company, I thought I'd give a quick background. I've been in the industry for 30 plus years and spent the first decade plus at Merck, and then progressively at smaller companies, both private and public, venture-backed, private equity-backed, a number of exits along the way. What attracted me to Life Biosciences, this reminds me of my early days at Merck, when the science was really pointing towards opening up entire new therapeutic categories, whether it be cardiovascular, lipids, arthritis. It was a new adventure every day. And as I had the chance to meet with Mahmoud and Joan Manick at this company, it was just too good of an opportunity to pass up. It's a mission-driven company. We share the same mission as Metabesity. Our approach is through hardcore science and evidence and traditional biotech drug development. We have 3 platforms that I'll get into in a second, but are keeping us very, very busy. As a reminder, we know that aging is the biggest modifiable risk factor for most chronic diseases, right? It's after the age of 65, we all think it was just because we're getting older that we're having these diseases, but we now know it's not just due to random wear and tear. And this is really important. There's biology, and it's about how we attack that. So aging is biology that may be targeted with medicines. And this really drives us internally at Life Biosciences. And it's finding the best biology and then developing innovative and valued medicines along the way is what we do every day. Where are we today? We are a preclinical stage company moving quickly in the short term to the clinic. We have 3 platforms. A mitochondrial uncoupling platform. As we know, increasing mitochondrial activity has the potential to treat a number of metabolic diseases. And then the work out of Ana Maria Cuervo's shop at Albert Einstein, chaperone-mediated autophagy. This is such a fascinating area, a new therapeutic category. The opportunities are limitless. We know now that restoring proteostasis can improve the function of aging systems in the retina and well beyond, as we'll see in a moment. And then finally, the work of David Sinclair, epigenetic reprogramming platform, building off of the Yamanaka factors with a twist to restore cellular function in ophthalmologic diseases, and it has potential well beyond. As I mentioned, we're near term to the clinic. We expect to have our first in human studies in NASH in 2022. And right beyond that, with our other platforms, we'll be initiating IND enabling programs and expect to hit the clinic in the subsequent years as well. The Life Biosciences has what I believe amassed the appropriate team for hardcore science and biotech with our R&D team and as well as our financial team. We'll get into that at the end of this presentation. So, we continue to push forward in developing innovative therapeutics that really focus on aging and age-related diseases. And we couldn't be here without just the world-class researchers, working with David Sinclair, well recognized in the field of aging, and then our friends at Albert Einstein, both Ana Maria Cuervo and Everest Gavathiotis. And we're just so proud to work with them. And then Kyle Hone and Webb Santos are at the forefront of our mitochondrial coupling program. So we look forward to continued partnership with them and we're benefiting from their work and their life's work. So we always are appreciative and thank them. The question is, what do folks think about our science? And wow, tremendous validation. Our science has been recognized in the world's most prestigious peer-reviewed journals. And in the course of a 12-month period, there was at least one paper in those journals for each of our platforms. So we feel like we're well validated with our biology and our hypothesis going forward. I'll spend a little time here on each of the platforms. A little more, I mentioned earlier, mitochondrial uncouplers are known to increase metabolism, decrease free radicals, and in preclinical species to extend life. What happens as we age, our mitochondrial couplers become less effective, less efficient, and their ability to remove unwanted material declines in many cases. It's been proven previously in a previous generation of mitochondrial couplers that was effective in weight loss but had toxicity. So what we're focused on is developing the next generation, right? Improving upon the history and the base of mitochondrial couplers, where we expect to, and we believe we'll be able to mitigate the safety risks of the original 1-DMP. So far, things look good, right? The animal models are confirming preclinical safety and efficacy. We're seeing everything you'd want to see, whether it's in obesity or in NASH with liver inflammation and removal of fat. As I mentioned earlier, we're on the precipice in the near term of entering the clinic for NASH. I think it's interesting just to look at some data that was published in our tool mitochondrial uncoupler compound BAM15, and looking at in a mouse model, right, chow, which is a standard diet, and then the Western high-fat diet. You can see in the graph on the left that we see the fat mass in a chow mouse remains very low. In the Western diet, elevated, and then in the Western diet prior to initiation of BAM15, you see that. What's interesting is you see a significant decrease in fat mass after treatment with BAM15, approaching that of the chow mouse, the chow diet. The big learning here is, and I think a big advance, is that we're able to significantly reduce fat mass, while on the right looking at maintaining lean mass, which is what you don't want to do. You don't want to both reduce fat mass and lean mass. That is not the desired outcome. So far, very excited about the findings here with our mitochondrial uncoupler program. Beyond that, looking at glucose and triglycerides, once again, we see with the Western diet treated with BAM15, we can mimic once again the chow diet. So this is very encouraging data on blood glucose. And once again, we see it with triglycerides generally, but then when we look specifically at the liver, the same thing, we're able to reduce liver triglycerides back to the chow diet fed mouse. And even with the oil stain and liver fat, replicated there as well. Fascinating data, very exciting, all full speed ahead, and we expect to be in the clinic in 2022. Turning to chaperone-mediated autophagy platform, as we mentioned, the CMAs remove unwanted proteins, sort of the trash trucks, right, of our cells, and the issue is there's a inverse correlation of the ability of CMA to remove unwanted proteins and aging when we have an accumulation of these unwanted proteins within our cells. So it creates a real issue, and part of this is due to the reduced expression of the CMA receptor LAMP2A. So to that end, we've really focused on this aspect, and we've identified compounds that increase the expression of multiple proteins in the CMA pathway, and most importantly, including LAMP2A, and thereby it's restoring CMA activity to that of a younger mouse. What's fascinating, we see potential utility in a number of areas, and probably more that we have yet to identify. with this target. Really interesting, and we couldn't be more excited about this data. So whether it's Alzheimer's or frontotemporal dementia, stem cell dysfunction, and as well as retinal degeneration. And I think the list will go on and on. We're not ready to disclose those right now. And we'll be in IND enabling studies next year. Just give you a little tease on some data in a mouse model of frontotemporal dementia. What's interesting, if you look at the, and this is with the, looking at tau. If you look at the normal mouse on the chart on the left, a normal mouse, when in an open field, it's just programmed to stay safe. And it will spend a vast majority of its time on the borders of that field to protect itself from prey. What happens in the PS19 mouse, and these mice are have an unfortunate life in that they accelerate and continue progressively to develop tau mutations. So what you see is the mouse does not behave normally, and it crosses the field. And so its cognitive function is declined. What's interesting, when we add our CMA activator compounds, the mouse returns almost back to that of a normal mouse in terms of activity, in terms of staying on the border of the field. And when we look at models of memory, the same thing occurs. And we see in the chart, the green, the control, the vehicle, we see a reduction in restorative memory, and then with the CMA activator compound, returning to that of the control mouse. So really interesting on a memory standpoint. And then we look at tau, right? So with immunostaining, control mouse, with you see no accumulation of mutant tau. In the vehicle, tremendous accumulation, and this continues progressively over time with the PS19 mouse. And then when we introduce our CMA activator, you almost go back to that of the normal control. So we're seeing it not only in behavior within the field, not only in mouse memory, we're actually seeing it in the amount of tau within the mouse. So really exciting data here. Our final program, the epigenetic reprogramming platform, a lot of news in this space with some other investments, and we're excited to have what we believe is the most advanced and a program that has the best utility going forward. The epigenome, as we know, consists of chemical modifications, right, that regulate gene expression. They turn them on, they turn them off, and it's very systematic. What happens is, oftentimes as we age, there's what's called epigenetic drift. And so what you see is genes that should be turned on may be turned off. You may have multiple genes turned on that shouldn't. And this is quite problematic, right, as we age and with regard to disease. And what's interesting in our proprietary program that came out of David Sinclair's lab is it reprograms the epigenome of these older animals back to that of a younger animal. And I think via the expression of 3 Yamanaka factors. And that's very important, as we'll get to in a second, that it's the expression of 3 Yamanaka factors. And the data we see so far, this is early, but the data so far is encouraging, and it's full speed ahead. No adverse safety findings in mice 16 months out. And then with in vitro injection of OSK gene therapy, we're demonstrating proof of concept in ophthalmologic conditions, increased nerve regeneration. We'll look at this in a minute, restored vision, and it significantly improved the vision in naturally aged mice. And along with our CMA program, we expect to initiate IND enabling studies in 2022. So let's look a little further here. We have what we're achieving or aiming at is a partial reprogramming with OSK gene therapy. And the goal is to return cells back to a younger state, right? To retain their original identity. And the difference between full reprogramming of 4 Yamanaka factors and partial reprogramming with 3 Yamanaka factors is that with the 4 factors, you return these stem cells back to an embryonic state. And when you do that, they lose their identity, and they have an increased risk of forming teratomas. And what David found is that by limiting it to these 3 Yamanaka factors, you return these cells to that of a younger state, but they retain their same identity. And this is really important. Now, looking at our CNS, it's unfortunately for us and for mice, it's one of the first systems to lose regenerative potential. In an embryonic state, quite active, can restore itself, can repair in an embryo. We see this with retinal ganglion cells in the central nervous system. And however, as an adult mouse, and unfortunately for us as well, the adult nervous system is not so restorative. And so you have the inability to really regenerate these cells as we age. Now to the work of David. What's fascinating is David took an optic nerve crush model, and you can see on the top without therapy, the control, and with OSK gene therapy, the brightness is new nerve growth. We see in the control very little to none, no new nerve growth, and in OSK gene therapy, tremendous nerve growth. And so this is phenomenal, right? So we're able to restore and grow new nerves. However, does this translate, right? Does this translate into a benefit? And yes, it does. Not only restoring electrical activity, but vision after vision has been lost. The chart on the left shows that with the introduction of OSK, we see the amplitude increase significantly, and this is important. And then we turn on the right, looking at OMR, which is a measure of visual acuity. We have the normal mice on the left. We have our mice with glaucoma. And then you have various treatment time in weeks with OSK, and we see the efficacy is maintained and the visual acuity is maintained out to 12 weeks. What's really fascinating about this is that current therapies in the glaucoma field are really only focused on reducing intraocular pressure, right? That's the end game right now. Our OSK therapy really has the potential not only to return IOP to normal, but to restore visual acuity. And wow, this is just groundbreaking and tremendous data. And we're excited to continue to move this forward. Our pipeline, we're really set up for a tremendous number of milestones and along the way. Out in front is our mitochondrial coupling program, but rapidly moving right behind is both CMA and epigenetic reprogramming. We have multiple indications we're looking at today. We have, as I mentioned earlier, many more opportunities. We'll continue in a very disciplined fashion to move these programs forward, continue to identify and justify additional indications. There's tremendous interest in all of these programs, and we continue to have those discussions. But our intent right now is to continue to move forward as an independent company. A little more about the team. The stars here are always in a biotech, the R&D team. We're just honored to have Joan Manick heading up our R&D. She's well known at this conference and in the field of aging. Her ability and her knowledge of the aging biology is just a tremendous asset to Life Biosciences, and her experience taking a program through phase 3 just lends tremendous guidance to us, and just a pleasure to work with Joan. Working with Joan is Jennifer Cermak, over 2 decades of early discovery, candidate selection. So we have the perfect balance of discovery, early candidate selection, and then Joan, who's had the ability to take things all the way through in our R&D team. Jennifer's led over 60 trials. Recent addition to the team is Bill Sullivan, our Chief Financial Officer. 25 years of corporate finance and strategic transactions. What's interesting is Bill has raised over $700 million financing, including taking Merrimack Pharmaceuticals public. He also was intimately involved in the sale an asset sale by Merrimack to Ipsen for over $1 billion. It's a pleasure to have him on board. And it's important as we lay out this company from a biotech perspective, it's having the right people in the seats. So we have the R&D team in place, and we have the financial structure and the financial expertise to lead us down the path, regardless of whether we stay private or we look to go public. We have the right person in the seat. So that's our story. We sit here, and I think it's the challenge of riches, right? We have 3 platforms, multiple shots on goal within each. Our challenge is prioritization and where to take our shots. We have a number of near-term milestones and many more lined up behind it. And as I just mentioned, we're thrilled with the team we have. We'll continue to size it and add the talent and the experience as needed in a disciplined fashion going forward. But we couldn't be more excited about the biology. We believe we have the best in the business, and about the opportunity we have across these 3 platforms. So with that, I'll thank you for your time.
Thank you so much for that, Jerry. I mean, obviously a heck of a lot of work happening there. Just a question for you, obviously, in terms of the plan for the business. Is the mission to go to IND enabling studies, or are you looking to fund through phase 1, phase 2, and then hand off in phase 3 under license deals? What's the kind of model that you'll be pursuing on that?
Yeah, so it's about creating optionality. We are, what I can say is we have the capital to go alone. We intend to take each of these programs with the capital we raise either through phase 1 and with a couple of others, at least to phase 1. And as we look at capital strategy going forward, there's a number of options, right? One, a traditional is crossover to IPO. Another, as we heard yesterday, there may be the ability also to stay private. Those are the things we will continue to examine. And that's why we brought in Bill Sullivan, our CFO, who has that experience, so we can create that optionality. But I'll make it clear, we are well funded today. And we are nearing the close of a round. And so our intent is to continue to go alone. That said, because of the diversity of opportunity across each of our platforms, and we've had untold interest and in our platforms, and I mentioned this yesterday, big pharma is looking, they're aware, they're scouting, and they are interested in these targets. And so our big question is, how do we, and the decision we make the decisions we need to make going forward is, what do we keep? What, if anything, do we license or partner? And what type of partnership does that look like? Is it a collaboration? Is it a straight out license? Those are decisions we'll be making. We've brought in professional help with that. It was just becoming too much for a company of 13 people to handle. So we've put in a professional process to manage it. And so we're excited about that, and we'll make those decisions going forward. Could we see ourselves with a partnership within a year or so? Sure. But if it's not the right deal, we have the capital to continue to go forward.
That's good to hear, Jerry. Well, I mean, obviously, a lot of exciting work going on there. And if you have the firepower to bring those various programs to market, that'll be very exciting for the sector. And of course, riding the big beast as you are now with some of those great people on your team, wish you the best of luck with however you go forward in the next year or so.
Thank you, Phil. Appreciate it.
Great, Jerry. Thank you so much for time.